Hi class, in this lesson we are going to just be looking at a bunch of examples for things, so this will be really helpful when we get to the story problems. The only thing I need to teach you before we do that is the difference between angle of elevation and angle of depression. For angle of elevation, we're talking about if you are, standing someplace lower, and we're talking about that's the angle between a horizontal as you look up. So I'll just write it's from the horizontal looking up. And the angle of depression is kind of the same type of thing. If you think about like where your eye would naturally be if you were just looking straight ahead, so the horizontal, and depression then would be talking about if you're looking down from something up high. So that's the difference. These are actually going to be two congruent angles, and it just kind of depends on how we're going to be setting up our picture. These will be congruent because they're alternate interior angles, and these lines here would be parallel because they're both, we're talking about horizontal. So this person's looking up to that person, that would be their angle of elevation. This person up here is looking down, and that's the angle of depression. Okay, so here are some pictures, or here are some examples we're going to draw pictures for. You'll get to see my awesome artistic skills in action with this. So it says a search and rescue team is airlifting people from a scene of a boating accident when they observe another person in need of help. If the angle of depression to the other person is 62 degrees and the helicopter is 18 feet, so let me just kind of go through some of this and underline it. Above the water, what is the horizontal distance from the rescuers to the person to the nearest foot? So really kind of the most important thing is that you're able to draw the right triangle and label this information where it goes. I like to make things a little bit more interesting, so I would, draw my awesome helicopter. Okay, you got the little rudder and the there's the helicopter, and then here's the water, and then here's the person in the water. They need some help. And I'm going to go through and I'm going to make my right triangle also, but then you can just kind of see this is the information I have. So this says the angle of depression. So remember, that's if you're looking straight ahead. This angle here, so that's not actually in the triangle that I drew, and I could draw this triangle a couple different ways, and I can show you another way in a second. It says that the helicopter is 18 feet above the water, and I want to know the horizontal distance, and this would be my right angle. So there's actually a couple different ways you can do this. Sometimes kids like to calculate this angle. I usually don't do that. I would just say, okay, if this angle of depression is the same as this angle of elevation, that would also be 42 degrees. So I would set this up, and I would write down, first of all, I guess, that this is opposite and this is adjacent. So I would set this up as the tangent of 42 equals the opposite 18 over the adjacent. And then I could cross multiply. So 18 equals whatever the tangent of 42 is times x. When I solve this, I need to divide by the tangent of 42. And this would be like the work that I would expect to see, some sort of picture and then setting up sine, cosine, tangent. And then I would go ahead and grab my calculator, and I need to type in 18 divided by the tangent of 42. Whoops. Calculator moved right then. 42. And the answer to this, after I round it, would be, I'd say that this right here is about 20 feet. And it would be okay to round that, especially because this is a story problem. So I would just say that that's about 20 feet. And I would be done with this one. We'll add in the word about for good measure there. Okay, so sometimes students say, well, I didn't draw my picture that way. I drew my picture you know, this way, and that's okay. This would also be 18 feet, and this would also be what you're solving for. It would still be tangent, it would still be set up the same way. Once in a while I get somebody that says, well, if this is 42, then can't I just subtract that from 90 and say that this one is 48? And you can. Then this would be set up tangent of 48 equals, then this would be the opposite over the adjacent, and you would cross multiply here and you would get the same answer. So either way these things work out. There's more than one option of how you draw your picture sometimes. For this next one's a little more complicated, and my picture will have to be a little bit more involved. It says that Leah wants to see a castle. So let's see, here's Leah, here's the castle, you know, that she wants to see. And she sights the top of the castle at an angle of elevation of 32 degrees. So she's looking here, and she sights the top of that castle at 38 degrees. If she knows that the castle is 190 feet tall, and she is 5.5 feet tall, how far is she from the castle to the nearest foot? So I guess this would assume that we're talking about this part here. You know, that she can't, like, she's seeing it from far enough away that this part here would be negligible, because I have to get that right triangle. So I want to know how far away she is from that castle. For this one here, you actually can't just use one number. You have to do some figuring first, and this is drastically not drawn to scale, so don't worry about that. But if she knows that the whole castle is 190 feet, and if she herself is 5.5 feet, that does not make this side here 190. That would make this side 190 minus 5.5. So the actual part of this triangle is only going to be 184.5 feet. And that's going to be the number that you need to use when you set up your sine, cosine, or tangent ratio. So from this angle, this is the opposite, and this one is adjacent. I would use tangent to set this up. Tangent of 38 equals the opposite. So in this case, 184.5 over the adjacent, which is x. I have to cross multiply this one also. Same thing here. When I end up cross multiplying, what I'm going to have to type into my calculator is 184.5 divided by the tangent of 38. So gotta go grab my calculator again. Let's see, maybe I'll move it over here. Hopefully you guys can see that. So 184.5 divided by the tangent of 38 equals the answer for this, and it says to the nearest foot, is about 236 feet. So I could just write the answer is 236 feet. And a lot of times for story problems it might just say round to the nearest foot, because that little bit's going to be kind of negligible. Again, for this, don't worry, you know, this obviously is not drawn to scale, and if she's seeing at a distance, maybe she's seeing like the front end of it to where she's just looking at the highest point. It's kind of hard to draw this, you know, three-dimensionally on this two-dimensional piece of paper, even though my art skills are pretty. And then for this next one, it's talking about a lifeguard watching a beach and the line of sight being 6 feet above the ground. So maybe the lifeguard's sitting on one of those like fancy lifeguard chairs, okay, and they see, I don't know why they always do this, like they're seeing somebody out in the water, Okay, this person struggling out in the water, all these lifeguards and helicopters, they don't really have a body, they're just like neck and legs and arms. But they're out there in the water, and it says here that this height, their eyeball is 6 feet above ground. She sees a swimmer at an angle of depression. So the angle of depression would be like if you thought about that straight horizontal. This is the angle of depression, so that's 8 degrees. I thought that was 6. And it wants to know how far away from the tower is the swimmer. So again, this is kind of like that helicopter one. We want to find that. Because they give us this angle of depression being 8, I like to just go ahead and put that there, because remember, these are alternate interior angles and those are going to be exactly the same. So I would set this one up. A lot of times these end up being tangent. They won't always be, but in this case it is, again, opposite and adjacent. So the tangent of 8 equals 6 over x. When I cross multiply, I'm going to end up having 6 divided by the tangent of 8. Going back to the calculator another time, I'm going to type in 6 divided by the tangent of 8. And the answer to that, it says well, we can just round this to the nearest foot, I guess it doesn't say. But this right here would be about 43 feet. If you wanted to say like 42.7 feet, if it doesn't say, I don't really care. Because the other ones we've rounded to the nearest foot, we can just do the same thing here. So we'll say it's about 43. And it is important to put units on that, so make sure that you add feet in. If you were in my semester class, you can stop the video here. This is all you need to see. If you're in advanced geometry, go ahead and keep watching. This next example is for you guys. This next example is about this tree that you want to get removed. And it says, to estimate the height of the tree she wants to remove, Mrs. Long sites the tree's top at a 70-degree angle of elevation. So it says here that when she's standing here, you don't see this in the picture, but when she's here, straight up that's 70 degrees. Then it says she steps back 10 meters and then sights it at 26 degrees. So we actually have 2 right triangles here we can write ratios for. It says if Mrs. Long's line of sight is 1.7 meters above ground, how tall is the tree to the nearest meter? So I don't really need to worry about this part yet. This will be important at the end. I first of all want to just look at these 2 right triangles and set up sine, cosine, or tangent ratios for those. The problem is I have 2 variables. So what we're going to end up here with is a system of equations, and then we'll have to kind of put them together to solve. So this first one, for this first little triangle, when I set this up, I have opposite and adjacent. So I'm going to set this up as the tangent of 70 equals x over y. So that's my first equation. The next one is also going to be tangent for this one here. So this would be tangent of 26 equals the opposite, which is x. And now, though, the adjacent is this whole thing, so I can say that that's y plus 10. What I want to do is I want to get this in a place that I can solve it, and I'm going to solve it with a system of equations. I'm going to solve each of these for for x, and then use substitution. So when I solve this one for x, I'm going to multiply y by each side. So x equals y times the tangent of 70. For this one, I would multiply each side by y plus 10. So this one's going to be y plus 10 times the tangent of 26 equals x. So substitution would say, because these both equal x, I can set them equal to each other. So, you know what, I'm going to change this around and I'm going to write the tangent of 70y equals, and I'm going to distribute here, the tangent of 26 times y plus the tangent of 26, and I'll put that one in parentheses, times 10. So what you have to remember is that these are just numbers, and you're going to have to use your calculator to get what those numbers are, and that's fine. This might be a good time for you to just grab your calculator and do these different calculations on here. You could keep going with just writing out like tangent and stuff, but it's probably a really good time for you to start just writing down decimals. So this is going to be the tangent of 70, and that is about 2.7475 times y. And if you're going to write a decimal, you need to have 4 after the decimal place, because otherwise your final answer will be wrong. The next one I'm going to type in, let's see, I got to keep going back and forth. The tangent of 26 is about 0.4877 times y. And the last one is the tangent of 26. And I'm going to close the parenthesis there before I multiply by 10, or you can push equals in between. That one there is 4.8773. Remember, I'm trying to solve this for y. So I'm going to be subtracting that number over, and whatever that is, I'm going to have something times y, and then remember what I'm going to have to do to finish solving is I'm going to have to divide by whatever that number is. So I'm just kind of getting this set up so that I don't have to keep going back and forth. I can just do all this work together. So I have 2.7475 minus 0.4877. So that's this number here. Well, I guess I will go back and forth. So that is 2.2598. And then remember, I'm going to have to be dividing by that to finish solving for y. 2.2598. So lastly, I have 4.8773 divided by 2.2598. So this answer for y is about 2.1583. We'll just round that off. This is not the final answer. We're almost there, but this is not it. This is what y is. I want to find x. I would take this and plug this in. It's maybe kind of hard to see, but I would plug it into that original equation here. We have the tangent of 70 equals x over y, and y is 2.1583. So I'm going to multiply that by the tangent of 70, and I just have that on my calculator, so I'll just push times tangent of 70. So that's this 5.9 number. Again, not quite the final answer. I said we'd come back to this part here at the end. That 5.9 something is this for x, but the height also has that part of the tree trunk. So the last thing I need to do, this will be our final answer, is just to add in that 1.7, the final answer for this, and I'm just going to round this, is about 7.6. So 7.6, the units on all of these were meters. So that is my final answer. I'll just make a little note here. You have to make sure that the final answer is x plus the 1.7, because you have to take into consideration this height here would be 1.7. So the whole tree would be 1.7 plus x. I'll do one more example for you guys if you need another one. I think this next one's a little easier if I'm remembering correctly. I'll try to remember to edit this part out if it's not. So for this last example, it says these two buildings are sited atop a 200-meter skyscraper. So if you have a skyscraper that's 200 meters tall, and we have these two different buildings at these angles of depression. So the first angle of depression is 35 degrees, and the next one is at a 36-degree angle of depression. The question wants to know how far apart are those two buildings. Okay, so this would be like ground level. Okay, we have these different buildings going on here. What I know from this is I know that I have these two different right triangles with these two different sides here. What I would do is either think about them separately if you need to, but I'm going to calculate how far this is and how far this one is, and then I can use that to tell how far apart those two buildings are. So for this first right triangle, the smaller of the two, the different angles are, or the only angle is 36 degrees. I know that this is 200 meters. I can go ahead and put that over here this time, that one's 200 meters, and I want to find this distance, which is going to be the same as that. I would set this one up. The tangent of 36 equals the opposite over the adjacent. I'm going to end up dividing here. So this is going to be 200 divided by the tangent of 36. This distance here is about, and actually I'll just put it over here, 275.2764. For the next triangle, for that bigger one, and it's actually not a bigger angle, but it's just, I guess I should say farther away from there. This is 35 degrees. This is still 200 meters. And this distance, the farther away one, would be what we're trying to find. So I'd set this up. Tangent of 35 equals 200 over x. When I solve this, I'm going to, on my calculator, type in 200 divided by the tangent of 35, and I get 285 point, let's see, so this number is 285.6296. What I'm going to end up doing then to just find this distance in between here is just subtracting these two numbers. So you can just make a little note maybe to yourself, we need to subtract these. So this one is going to be, let me go back to my calculator, I'm going to subtract 275.2764, and the answer is about 10.4 meters. So I can get rid of this. Oh, and actually it just says to the nearest meter, so the answer to this would be about 10 meters. So hopefully this one was a little easier than the last one. You didn't have to do a system of equations. Sometimes you will and sometimes you won't, just kind of depending on what they give you as you start out. So I look forward to helping you guys with this in class. I hope that you guys have a spectacular day.